Now we will look at question 3. Let me use a black pen. Now question 3, it says given. Now this is f of x. It's equal to 2 divided by x minus 1 plus 1. Now 3.11 says write down the equation of asymptotes of f. We know that the equation of asymptotes, we're having the horizontal and the vertical asymptote. And then we know that the y asymptote will always say y, it's equal to the this value, which is 1 in this case. And then we also having x minus 1, it's equal to 0. Therefore x is equal to 1. So those are your two asymptotes. Now 3.12, it says sketch the graph of f if points 0 and -1 and -1 and 0 lie on f. Show all asymptotes. Now we know that if you want the y-intercept, so this will be the y-intercept because x is 0, and then this will be the x-intercept because y is equal to 0. Now when we sketch, we know that we always have to start with our asymptotes. So let me first draw my Cartesian plane, which is x and y. Now remember the value of a, the equation of your hyperbola, it's given as f of x and then a and then x minus p plus q. So the value of a influence how the shape of your graph will look like between your asymptote. If a is greater than 0, then your asymptote will your graph will look like this between your asymptotes. It's almost like the first and the second and the third quadrant, but remember your graph will have shifted either left or right or up or down. In this case, f of x has shifted 1 unit upwards because this is associated with the upwards movement. This value where we're having +1, this is a up or down movement. When it says plus, it means the graph has shifted 1 unit upwards. And then this x minus 1, it's a shift that moves your graph either left or right. And when it's negative, it means your graph has shifted to the right 1 unit. Now when we sketch our hyperbola, we need to start with our asymptote. We have our asymptotes as x is equal to 1. So we'll start with that asymptote where we are having x is equal to 1, and also where we are having y is equal to 1. Now we are having our 0 and -1, our y-intercept as 0 and -1, so we can say this is -1. Remember y-intercept, x is always 0, and then we are also having -1 and 0. So the first part of your hyperbola will be in this fashion. Now the second part, remember you are having 1. You can substitute any value. Let's substitute 2. When we substitute 2 on our function, so f at 2, we are going to have 2 into 2 minus 1 plus 1. which will give us what? 3. So 2 and 3. So we can have another point there. So it means our hyperbola will look in this fashion. So we know this is 2 and 3. Now 3.13, it says write down the domain, the new domain, if your graph of f is shifted 2 units to the left. Remember I said if it says plus 2, the shift is to the left, and then the y value you take it as it is. If it says plus 1, it means it has moved 1 unit upwards. So our asymptote that we have for f of x, currently it's 1 and 1. We had our asymptote as x is 1 and also y is equal to 1. Now after the shift, our new asymptotes, after the shift f x plus 2 plus 1, now our new asymptotes will become 1. Remember you need to solve this. If it's x plus 2, this will become x minus x is equals to negative 2. So when you substitute this, you need to substitute as negative 2, unless you can only substitute as x plus 2 when you substitute on the original equation where you see x. But if